This is AP Physics Electrostatics video number 3. This one involves creating motion of a rolling can using electrostatic forces. The goal at the end of this one is that in the comments section you'll predict what my best time is to roll a can using a charged plastic rod like I used in video number 2 to make the can roll across the table, a wooden table that's flat, pretty flat. So that's what your goal is. That'll also be your means of taking attendance on this class session, the second session of the first Cyber Week. So that's your goal at the end. All right, so I want to show you some physics related to it first, and it'll help guide your thinking a little bit. So the question is, how fast can a can roll across the table? If I used a force that was like what we had the other day between the two latex balloons, it was about 1.6 times 10 to the minus 4th newtons. If I used that force to accelerate a can all the way across the table, the work that would be done was that force times that distance, and that would be about 1.6 times 10 to the minus 4th joules. So if the work energy theorem is true, the kinetic energy change is equal to the amount of work that was done, then that change in kinetic energy, which I'm pointing to right down here, those two terms added together ought to equal that work. So this is the rest of the calculations. If the mass of the can is about 20 grams and those two kinetic energy terms add together, it turns out that we should have about 0.75 mv squared equal to that amount of work that's done. And if that amount of force and that amount of work is accurate, then what we yield here is a final speed of around 0.1 meters per second. That's 10 centimeters a second. So that's if that relationship like we had, like 10 centimeters between the balloons, was true for the same case right here with the plastic rod and the can. Okay. So with this though, if that situation was true and it accelerated the whole time, its average speed going across the table would be half of its final speed. That's what's written there. And then if that average speed was projected over that whole 1 meter, it would take 20 seconds for that can to roll across the table. Okay, so it's probably not a surprise to you that I can do better than that. Okay, and of course the reason why is right, the can wants to accelerate much faster than that because why? Well, you know, the rod is a lot closer to the can now than I'm not keeping it 10 centimeters away. So that's really hard for me to do when you do this. You can try doing it on your own. Oops. You can try doing it on your own if you have a plastic rod. It doesn't have to be PVC, and you have something. Doesn't have to be cat fur. It could be something wool or something else that's going to put a decent charge on the plastic. And if you have an aluminum can, you can try it yourself. That'll improve your odds of guessing about how much time it's going to take me to get this can to roll across the table. So if I did keep the can 10 centimeters away from the rod at all times, it probably wouldn't be a bad answer. Okay, but I'm not actually doing that. I'm going to try to make it go faster than that. I'm going to let the can get up nice and close to the rod, maybe even touch it. That's not really helpful, but if it did touch it, it wouldn't be a disaster because it's an insulator. I'm going to pull that can across here as quickly as I can and see what my best time is to go across this table for about 1 meter. So what your goal is for this video is to, well, first of all, I'd like you to go back and try to make sure you understand what physics was on the papers that I showed you. And the second thing is to make a prediction about what the best time I'm going to get for rolling that can across this table is. And then you write your answer in the comments section down below, and this will be the one that you have to comment on for attendance on either Thursday or Friday of this first Cyber Week. And then we'll see who's closest, right? So also in the second, actually I'll send you the answer to the first challenge probably via email so everybody can see what that angular separation was, and we can see who was closest on that one. So that'll be coming up soon to you too. Okay, so on this one again, best time that I'm going to be able to get rolling across the table you want to practice this on your own, try it yourself, so you have something to compare it to. Terrific, awesome. You don't have to, but it might be fun for you to try too while you're home. All right, okay, bye.